Towards the 19th century, the study of logic also started including a different type of argument, a different type of syllogism, typically referred to as a conditional or hypothetical syllogism. And this kind of argument typically consists of a conditional premise that states a rule. For example, the rule if P, then Q, where P and Q can be any type of proposition that we want. One important piece of language, which will be handy throughout this section of the lecture, is that P, whatever is in that position, is often referred to as the antecedent. So whatever comes before the then is referred to as the antecedent. Q, on the other hand, whatever proposition is here, is referred to as the consequent. So a conditional argument might look something like this. If it rains, then I take an umbrella. So that is my if P, then Q. Then I observe that it rains. Therefore, I can safely conclude that I will take an umbrella. And see, just as we discussed in the context of categorical syllogisms, also in the context of conditional syllogisms, validity is a formal property. Again, it depends on the logic structure of the argument, on the entailment from premises to conclusions. It does not depend on the specific semantic contents, on what specifically P and Q stand for. Indeed, to give you an example of this, in the immortal words of the Icelandic post-rock band Sigur Rós, I could say the same argument, and it could be if Eger komin aftur, then en stoppas tut vid, premise one. My premise two, my observation is, oh, look, Eger komin aftur. And so even though I haven't got the slightest clue of what any of this means, I'm forced to say, well, I guess I have to conclude, therefore, given premise one and premise two, that en stoppas tut vid. And you know what? I can't even imagine a world where the conclusion wouldn't be the case, despite having no idea what we're talking about. Okay, so this is another example of the fact that validity in this context really is a formal property. It's about the logic argument. It's not about what are P and Q. So indeed, you could boil down this argument to its logic form, which might look something like this. If P, then Q, which is my premise number one. Then I affirm P as my premise two. Therefore, I conclude Q. Now, this argument is also known as a modus ponens, or affirming the antecedent. See, I have this rule, P and Q. I affirm the antecedent. I say, oh, look, I see P, which is my second premise. And therefore, I can conclude Q. Now, this type of argument, very easy. People solve this argument with great ease, above 95% correct, typically. And this argument is indeed valid. People, as I said, have no trouble recognizing it. And just as for categorical syllogisms, if you change the logic structure, you're changing the argument. Take this argument, for example. If the block is large, then it is blue, premise one. Premise two, or observation. Oh, look, the block is not blue. Does it follow that the block is not large? Valid or invalid? And see, this argument is known as a modus tollens, also known as denying the consequent, right? If you look at premise one, if the block is large, then it is blue. What my premise two does, it denies the consequent. It denies the second half of the rule. It says, nope, I don't see a blue. I don't see something that is blue. Therefore, can I conclude that the block is not large? Well, see, this is a much harder argument to resolve. And indeed, the logic structure of it, compared to the one we saw before, is very different. Earlier, we saw if P then Q, P as premise two, therefore Q as the conclusion. Here we see if P then Q, then we deny the consequent, not Q, and we ask, does it follow that not P? And this is known as a modus tollens, or denying the consequent. And this argument is valid, but people really tend to struggle with this. Usually just about somewhere close to 60% is on average how well people tend to resolve this argument. But see, let me try to help you see why it's valid. Think of it this way. So if the block is blue, I'm sorry, if the block is large, here, actually, let's do it here. If the block is large, then it is blue. The block is not blue, therefore it has to be that the block is not large. You want to know why? Well, because if the block were large, what would I see? Well, I would see that it is blue, but it can't be blue. Therefore, it can't be large. Why can't it be large? Well, because if it were large, how would it have to be? Blue. But I just told you that the block is not blue. Well, then it can't be large, because if it were large, et cetera, et cetera, et cetera. Okay, so hopefully this convinced you that modus tollens is a valid inference, even though there's a very large literature supporting the fact that it's just not intuitive. For whatever reason, modus tollens, it's just not the way in which we tend to approach these type of problems. It just does not seem intuitive to us. We generally struggle, and proof is, we test you on SATs to see how well you do on these things, because they really are not, for some reason, they really are not intuitive to us. And according to different theories, the reason why this is hard might be different. Now, at this point, you've seen that in the first type of argument, the modus ponens, we had if P then Q, and we affirmed the P. So we called that modus ponens, or affirming the antecedent. This argument, instead, we call it a modus tollens, or denying the consequent. So we had P and Q, and we deny Q. So now we can do the same game, but with the other proposition. So, for example, we could affirm the consequent. So if I have if P then Q, and I say Q, and I see Q, what follows? Okay. So it would look like this. My rule is still if P then Q. My premise 2 is Q, so I'm affirming the consequent. Does it follow that P? Well, here, let me put some words on it. If the block is large, then it is blue. The block is blue, does it follow that the block is large? Valid or invalid? Feel free to pause if you don't want me to tell you. This argument is invalid. And indeed, people struggle with this. Usually the rates at which people get it correct are at 40%. And the reason is that the rule is telling you that if the block is large, then it has to be blue. But it doesn't tell you that there can't be several other ways in which the block could be blue. All we know is, look, if it's large, then it's got to be blue. It doesn't say that if it's blue, it also has to be large, right? It only goes one way. And people struggle with this because people tend to interpret the first premise as if the block is large, then it is blue. And it's also the only way in which a block can be blue. So people tend to see this as a double implication, that the block is large if and only if it is blue. But of course, that doesn't necessarily have to be the case, right? The block could be blue under many other circumstances. I'm going to give you an example of that in just a moment to make it sort of more concrete. And finally, we can round out sort of this quartet of arguments by denying the antecedent, the last thing we haven't done, right? If P, then Q, let's deny P. Does it follow that not Q? And again, this is known as denying the antecedent. Let me put some words on it. Not that it should matter, since we know that it's a formal property, but maybe it's just more fluent to read it. So if the block is large, then it is blue. If the block is not large, does it follow that the block cannot be blue? Again, invalid. And people seem to struggle with this a lot. people have a hard time recognizing that this is an invalid argument. Okay, let me do this. I created a little cheat sheet for you to put all this together, also with some examples that might sort of help you better understand why some arguments are valid and some arguments are invalid. So here it is. Let's do it one at a time. Essentially, I'm just going to repeat in this more compact fashion what we just discussed, just to try to give you a different way of thinking about this and of understanding what is valid and what is invalid and why. So here we are. Our premise, as usual, is the rule if P, then Q. Okay. So let's start from here. Let's first affirm the antecedent. So to affirm the antecedent, my second premise has to affirm this, which is P. So if P, then Q, second premise P, does it follow that Q? Absolutely. This is known as a modus ponens. And people, as we said earlier, really have no difficulty recognizing that it's valid. On an example, this would be, if it rains, I take an umbrella. It rains, therefore, I take an umbrella. Makes complete sense. It's hard to even imagine a world where the conclusion wouldn't follow. Now let's, instead of affirming the antecedent, let's affirm the consequent. So premise 1 says if P, then Q. Premise 2 says Q. Does it follow that P? And as you can see from the generous red rectangle, this is invalid. And people struggle with this. They usually get it right 40% of the time. But let me give you an example to see if it helps. It will look something like this. If it rains, then I take an umbrella, right? Same premise 1. Premise 2, I take an umbrella, therefore it rains. Invalid. I mean, if you think of it, there are many other reasons I could be taking an umbrella. Maybe there's a blazing sun. That'd be a perfectly good reason to take an umbrella. See, all that P1 says is that if it's raining, then I take an umbrella. It doesn't say that that's the only circumstance under which I'm taking an umbrella. I could be taking an umbrella for a million other reasons. So just because you see me leave the building with an umbrella does not guarantee that it's raining. It could be raining, but it could also be very, very sunny, and I just don't want to burn my fair skin. Now, so we've affirmed the antecedent, and we affirmed the consequent. Now, let's deny the consequent. So again, the premise is if P, then Q. So we deny the consequent, we deny Q. So premise 2 is not Q. And the conclusion, does it follow? Not P. Absolutely, this is valid. And this is a modus tollens. Right? And an example of this would be, if it rains, I take an umbrella. I do not take an umbrella, therefore it does not rain. Why? Well, because if it rains, I would have taken an umbrella. I did not take an umbrella. So it cannot, the one thing I know is that it cannot be raining. Why? Well, because the first premise tells you that if it were raining, I'd be taking an umbrella, and I didn't. So what do you know? That it can't be raining. Why? Because if it were raining, I would have taken an umbrella, but I didn't, etc., etc., etc. So hopefully from now on, you'll never miss a question on a modus tollens ever again in any test you'll ever take that has a modus tollens in it. So we've denied the consequent or done a modus tollens. Finally, let's deny the antecedent. So if we have if P, then Q as premise 1, premise 2 would be not P, and the conclusion would be not Q. And this again is invalid. And an example of this would be, if it rains, then I take an umbrella. It does not rain, therefore I do not take an umbrella. Well, clearly invalid, right? Because again, the premise 1 just says that if it rains, I take an umbrella. If it does not rain, it does not guarantee that I won't take an umbrella. Maybe there's a blazing sun outside. I want to have an umbrella. All that premise 1 is telling you is that if it is raining, I'm taking an umbrella. That's it.